Hello friends, a quick video for a dockside motion sensor calibration. If you haven't seen my previous video of the dockside calibration for GNSS and heading sensor, you must see that first. So, if you are ready, let's start. So in this today's motion sensor dockside calibration, I am going to tell you a very simplistic way that you can do this calibration. And for this calibration, you need only two auto level, two touch step, and that's it. Yes, of course, you need a laptop so that you can log the vessel's motion in your laptop. So what you are going to do? First of all, set up your laptop in the bridge of the vessel and start logging their motion data. Now create two stations onto the jetty from where the vessel must be completely visible. The deck of the vessel must be completely visible, and go in the vessel and set up two offset points at the port and at the starboard, at the bow and at the stern, preferably in line with the vessel's fore and aft line. Now set up your auto level, one in this point and one at this point. Now from these 2 points, you shoot at the touch step at this point and shoot at this touch step at this point on the vessel. It has to be simultaneous and your clock must be synchronized. So by doing this observation, you will come to know which side is higher and which side is lower. Now I must tell you, before you do this observation, these two stations are on the jetty. You must know the height difference between these 2 points. Now with all this data from this station and from this station, you continue taking minimum of 50 sets of data. With this data, you can find out which side of the vessel is going up and which side of the vessel is going down and by how much. So if you know what is the distance between these two stations, you can find easily the tan theta, and that is the roll angle of the vessel. And you compare it with the logged data from the vessel's motion sensor. Same way, once you have taken 50 sets of data, you set up your touch stuff at bow and at the stern. Remember, they should be visible from the jetty. And from the jetty, the surveyors will take a shoot at this bow and at this stern of the vessel. Ulta bol gaya. Now you must carry out at least 50 sets of data again here, and they have to be synchronized at the same time, exactly same time. With these sets of data, you will come to know how much the vessel is moving up and down, bow up or bow down, and you know what is the distance between these two stations, and that way again you can find the tan theta of the vessel, which is again the pitch angle, and then compare it with the vessel's motion sensor data. Okay, have you ever seen such a beautiful, normal, easy explanation ever before? How much time will it take for you to do this observation? If you are a good surveyor, then you can do it much better. You don't need to know the position of these 2 points. Not at all. You don't need to carry out any DGNSS system. You just need couple of auto level, couple of touch step, a tape measure, maybe a dystometer, so that you can measure the distance between those 2 offset points, and that's it. Mark 4 points on the vessel, 2 points on or parallel to vessel center line, and 2 other points in the midship at 90 degree to the center line. The points must be as far apart from each other as possible. Mark 2 points on the jetty from where the observation will be done. All the points on the vessel must be visible from the jetty points. Sync your watch, observe heights of marked points on the vessel along the center line. Observe some 50 readings. Now switch over to port and starboard points and again carry out 50 sets of observation. Remember to sync your observation. Next, observe the height difference between the points on the jetty. This is an example of just one set of observation. We see that aft section jetty point is higher by 0.2 meter from the forward point. Measured distance between vessel's forward and aft point is 50 meter, assumed here. After some calculation, we see that the vessel's aft point at the time of observation is 0.45 meter higher than forward point. So we need to adjust the height between the vessel's points, and we are looking to find theta value. Simple tan theta formula gives us theta value and pitch angle to be 0.29 degrees. So this shows that bow is down by 0.29 degrees. Now we need to match this data with logged motion sensor data at exactly the same time, which should come as a negative value if the bow is down. It is not necessary that the vessel's motion sensor will show negative value. We just need to find the C-O between the motion sensor and observed values 50 times and take average and apply pitch correction. Similar calculation is to be done for port and starboard points to find the roll correction value of the vessel. Remember to synchronize your watch with the vessel's system's time. And this is, my friend, is the dockside motion sensor calibration. Now there are many other different ways to do that. Or you can use a total station and auto level when the vessel is at even keel in a dry dock. But that's too complicated. Nobody has the time for that. So this, my friend, is one of the easiest way to carry out a dockside motion sensor calibration. If you like this video and learn something new, then give me a thumbs up and write a comment of encouragement below. If you like what I do, then please support me by joining my community. So as always, be curious, and I'll see you in the next video.